And what we're going to do is talk about the APY. The APR is the annual percentage rate. The annual percentage yield is not exactly the same thing. So we're going to talk about the APY. So as an example, we're going to compute the accumulated balance for $500 invested for 1 year at 8% simple interest. Now this is not something we're going to do with the TVM solver, and the reason that we're not going to do it with the TVM solver is because it's simple interest. And when it's simple interest, like this first problem, then we're always going to have to use the simple interest formula. Interest equals principal times the rate times the time. So in order to compute the accumulated balance, first we have to accumulate the interest. So the way that we're going to do that is we're going to calculate the interest. By looking at the principal, which is what we invested, that's $500, times 8%, and when we're doing the rate with the simple interest formula, that does have to be converted to a decimal. Move the decimal from after the 8 to 2 places to the left to make it 0.08. And then the time is 1 year. And the time is always in years, so that's just going to be 1. So we'll get the calculator, clear it off, multiply 500 times 0.08 times 1, not that the 1 really matters, and we get $40. Okay? Now the $40 is just the interest, it is not the accumulated balance. The accumulated balance is all of the interest plus what you invested to start with. So we'll call that A for accumulated, and that is the principal plus the interest. So that's going to be your original $500 plus your interest of $40. So the accumulated balance is $540. And then it says calculate the relative change in the investment. A relative change, we know, is a ratio, or we usually express it as a percentage. So the accumulated balance is 540 minus 500 for the interest. That's what you have to find, is you have to find the absolute first. So the absolute change since we know that the difference is from 500 to 540, that means it went up. So we would have to subtract 540 minus 500 because we knew that the absolute difference is going to be positive because it increased. And then that means that the relative is going to be the $40 increase divided by your reference value. And for this to be positive, that means your reference value had to be 500. So that's not changed from when we actually first started the class. And then 40 over 500, if you do the arithmetic on your calculator, actually turns out to be 8%. Okay? And that should make sense because the interest is what we actually accumulated. And the interest is 8% of the original balance. But that's only because we're doing simple interest. Now in the next problem, it says to calculate the accumulated balance for the same amount, $500, invested for 1 year at 8%, compounded annually. Now for that, we're going to do the TVM solver. We're going to go get the TVM solver, which on this calculator is second x to the -1 to get to finance. Select the TVM solver, and the number of payments per year and compoundings per year is going to both be 1. So that's the value of C/Y and P/Y. The number of payments per year, or the number of times they're going to compound and pay, is only also going to be 1 because it's once per year. So it's like once because it's once a year times 1 year, which is still going to be 1. So that's why it's actually going to turn out to be 1. Our principal is what we put in to start with. That's what we would call present value. That's the $500. We're not going to make any payments. We're not going to pay anything else out. Now the $500, because we're putting it in the account, that's cash going out, so we're going to enter it as a negative. So keep that in mind. Anytime you're actually depositing money, that's a negative. If you're getting it, it's positive, but if you're paying it out, it's negative. And then the future value is going to be the accumulated. It's going to be our accumulated balance. Both of those are 1. And the payments that they're going to make us are going to be at the end. So if we don't leave our money in there for the whole year, then, you know, they're going to give us no interest. You have to leave it in there for the full year. So they're going to give us the money at the end. So let's enter that into the calculator. Interest rate again is 8%. I think I left that out. And this time we're going to enter the 8% as an 8. So that's going to be just 8. Present value is going to be 500. No payments. And the future value is what we're solving for, so we're going to hit alpha and enter to solve, and it says negative 540 because that's what they're giving us. That's going to be coming back to us. And that's because I forgot to put in a negative here. So if I redo this like I should, alpha, enter, then that's going to be positive. Okay? So the accumulated balance is positive $500. I'm sorry, $540. So that's the same as for simple interest, which means then that our absolute and our relative are going to be unchanged. So you're saying, well, you know, what is the difference? Well, there is no difference if all you do is leave it there 1 year. They're going to compound it once, give you the money at the end of the year, and that's the same thing as simple interest for that 1 year. Okay? But it's not going to be the same if it has a different compounding period. So we're going to go on and we're going to try this for different kinds of compoundings and see what changes. So again, we're going to take $500 for 1 year at 8% interest, but this time we're going to compound it quarterly. Which means 4 times a year. So when we set up our TBM solver, this is going to be the present value once again. This is going to be the number of years so 1 year times 4 payments in that year. So when we set up our solver, it's going to look like this. And the interest is again I, which is 8%. So what changes is how many times are we going to compound? We're going to compound 1 times 4, or 4 times a year. And that means that C/Y and P/Y are both going to be 4. And again, we're making no payments. We're depositing the initial or present value of $500. And we want to know again, what is the future value? So we're going to solve, and we see that we get a little bit more money this time. We get $541 and 22 cents. So that's going to change our absolute difference since this is going to be 541.22 minus 500, it's going to be the same setup as we did before. Our absolute difference is positive $41.22 divided by the reference value, which is going to be 500.
You mean 541.22?
That's the future value, but our actual absolute difference is 41.22. And then when we change absolute to relative, that's going to be 4122 over 500. And again, it's positive because we gained money. And that's why the 500 is going to be your relative. So 4122 divided by 500 is 0.08244. So when we change that to a percentage, that's 8.24%. That's the relative change in the investment. Now notice what happened that's different this time. Before, 8%, 8% if it was simple interest, still 8% if it was compounded annually. But when you start compounding quarterly, you get 8.24%. That's an additional 0.24%, almost a quarter of a percentage point. What do you think is going to happen if we compound more often than quarterly? You're going to get a little bit more money, which means that your relative change in the investment is going to be a little bit larger a percent, right? So again, go to our finance menu, and the only thing that's going to change here, 500 remains the same. That's still your present value. 1 year. Okay, that's still the same, but N is going to change because it's going to be 1 times compounded monthly. How many months in a year? 12. So you're going to have N is equal to 12. 1 times 12 is 12. C/Y is 12. P/Y is 12. And your interest rate is still 8%. So N equals 12. Present value equals, again, negative 500. Payments is still going to be 0 because we're only going to make the initial deposit. Future value is what we're looking for. C/Y and P/Y are going to be 12. So that's the only changes we're going to make. And we want to find the accumulated balance, which is your future value. So I'm going to go 1 year times 12 compoundings in that year. C/Y is 12. P/Y is 12. And go back up and solve for the new future value. Alpha, enter to solve. And this time, we have accumulated $541.50. That means your absolute difference is going to be your $541.50 minus the 500, which is positive $41, and this time 50 cents, which then we'll use to calculate the relative difference, and that's going to be $41.50 divided by 500. somehow that's, not 541.50, sorry, 41.50, duh. And that's 0.083. Which is 8.3%. So there again, a little bit more relative change, a little higher relative change. Now we're going to do it one more time. Still have $500. Still going to be 1 year. Still at 8%. Now it's going to be compounded daily. So N is going to be 1 times what? 365. Good deal. So C/Y and P/Y are both going to be equal to 365. And again, what we want is the accumulated balance, which is your future value. So we'll just go back second, x to the -1 to the solvers, to the finance functions, and then to solver. And N is going to be 365, 8% interest, $500 initial deposit, no payments, compoundings per year 365, and that's the same for C/Y. And we're going to solve for the future value. And now we get $541 and 64 cents. Now notice we didn't get a lot more money each time, but we got a little more money, a few more cents each time. So if we subtract 500 from our future value, that gives us our relative, our absolute difference, which is $41.64. And that means then that our relative change is $41.64 divided by 500. And that's 0.08328. Which would round to, again, 0.08, but I'm going to carry it out to the additional decimal place so that we can see that it's going to be not just 8.3%, but it's going to be 8.33% rounded off to the extra decimal place, which is, again, a little bit more. Okay? So if you compound more often, the relative change is going to be a little bit higher. You're probably sitting there saying, okay, and why are we doing that? You know, it's not that much difference. What's the point? Well, the point is, that suppose that was $500,000. That's $500,000. Well, the relative change isn't going to change much, but the actual amount of interest you gain is going to be quite a bit more. But these are all going to be the same, for the same interest rate, just different compoundings. What we're actually doing this for is because we want to talk about something called the APR versus the APY. The APR is the annual percentage rate. That's not necessarily exactly the same thing as what the APY is. The APY is the actual percentage by which the balance increases in a year. In other words, it's the relative change for a year. It's equal to the APR only if the interest is compounded annually. It's going to be greater than the APR, as we saw in that problem. It kept getting a little larger. It's going to be greater than the APR if the interest is compounded more than once a year. The more often it's compounded, the higher the APR is actually going to be. Okay? So what you need to know is the difference between these two. APY is the interest rate the bank tells you up front, or whatever your lending institution tells you up front. Okay? They always tell you the APR, the annual percentage rate. But the APY is the actual percentage that you can expect to actually gain. It's the relative change. And the APY is going to be higher than the APR if the compoundings take place more than once a year. Now, if you're getting interest on an investment that you put in the bank, that's a good thing. But if you're paying off a mortgage or a car payment, you know, the more often they compound interest, that means the more you have to pay them. So you have to think in terms of both ways. You can actually find the APY without calculating the way that we just did. If you know the APR, you can calculate the APY. The syntax for the problem is going to be the effective rate, and you're going to give the annual percentage rate, and then how many times per year is it compounded. So if you go to your finance formulas, and you scroll down until you find effective, or EFF. Which is all the way down at letter C. Okay?
I'm not finding it.
Okay, go to your finance, which is the same place as TVM Solver. And then scroll down. To EFF parenthesis. And when you get there, somebody's going to have to tell me because I'm not positive. I think it's on letter C at both of them. Let me check on mine up here. Yeah, it's on letter C on the 83 and the 84. So you have to scroll down quite a ways. And then you're going to enter in the interest rate and the compoundings per year. So find the APR of 8% compounded quarterly, monthly, and daily, and find APY. Now, we've already found it the hard way. Let's find it the easy way. So we choose effective, and our annual percentage rate is 8%, so we're going to enter in 8. And quarterly means we're compounding 4 times. And that gives us 8.24, which the comma is right here above the number 7 key. Okay? And we would normally round this off to 2 decimal places. And the only difference in that and monthly is that we would enter 8, 12 for 12 months a year. And we get 8.2995. Which again, we would round off to 8.30. Looking at this 9 says raise 0.29 up to 30. And then daily, it would be 8, 365. And that will be 8.3277. $57179, which we would again round off to 8.33. Okay? So there's your APY for each one.
The Y and APY is a yield.
Yield. APY is annual percentage yield. Okay? And although we've talked about it before, you know, just out of curiosity, this is not asked actually on that, just out of curiosity, what if it said compounded continuously? Well, then we would do the same thing. We would do EFF, enter our percentage rate, and then for continuously, you can either multiply out and put in the final answer, or you can do the multiplication actually right here, I'm pretty sure. You do, okay, that's, if it's continuously, there's 365 days in a year, times 24 hours in a day, times 60 minutes in an hour, so compounded every minute. It would be 8.328706108 But if you look and you've rounded it off, it's not gonna be a bit different. From compounding daily. It's not gonna be appreciably different. Okay? Any questions? So you could calculate effective rate the long way like we did before, having to compute by the actual accumulated value and then find the relative, the absolute difference and then the relative difference. And the relative difference is your APY. Or you can simply find your effective rate, which is what your APY actually is. The calculator will do all the arithmetic for you. Just remember how to find it. Okay? Now, another thing we're going to talk about in Unit 4 is something called an endowment. An endowment is an account that provides a permanent source of income without ever reducing the principal. One of the most common uses of an endowment is when we have here at the college something called an endowed scholarship. And what happened with that is that someone contributed a large lump sum and said, I want this money to be used as an endowment to fund a scholarship for students majoring in business or students that are majoring in fine arts or some other criteria. The way that works is, and the one that I know about is Dr. James Pierce has a $100,000 endowed scholarship. Now that doesn't mean the student gets the $100,000. The $100,000 is held and put into the bank and it gains interest or it's invested. The scholarship is funded by the interest off that $100,000. And eventually the interest accumulates enough that the scholarship becomes two scholarships because we have more interest as time goes on because the interest keeps accumulating, so we'll have enough money to give more than one scholarship. So basically you never touch the principal. You only want to live off the interest. It's a really nice thing if a person could actually do that with their annuity. They could dump in a lump sum and be able to live off the interest, but most people can't. But sometimes, you hear about people that, well, he was born with a silver spoon in his mouth. Well, that means mommy and daddy put a lump sum in the bank or invested a lump sum for that person, and that person's living off the interest on that lump sum. But they can't touch the lump sum. All they do is they get to spend the interest. The principal is restricted from them.
Is that how a trust fund is done?
That's the way a trust fund works. Now, they can set up a trust fund to where the person at a certain age gets the whole entire thing. But usually, if parents are smart, since, none of us are very smart when we're 18 or 19 or 20, we'll spend all the money. If the parents are smart, they'll set it up to where they can only access the interest until they're of a certain age. So, and this is an example of an endowment. It's just not a very common example. Unless you happen to have some kind of let's say you won the lottery. Now, before anybody gets excited about winning the lottery and doing this, I also teach statistics, okay? And the example I have showed my students in class several times, how many people want my dollar bill to go buy a lottery ticket? And of course, everybody wants that dollar bill because they want that lottery ticket. They don't want to go put the dollar bill into buying something to eat or anything else. So I tell them, okay, this is your dollar bill. You bought a lottery ticket with it. Bring my lighter in here, strike a match, and light it on fire, and watch it burn. And they'll say, but why did you do that? I said, well, that's the exact chance you had of winning the lottery. None. Yes, somebody's going to win. But generally the people that win are people that go in pools and buy hundreds and hundreds and hundreds of lottery tickets. Each ticket has the same probability of winning. The only way they have higher probability of winning is because they've got a whole bunch of the tickets. Okay? You have a higher probability of being struck by lightning twice in the same field during the same storm than you do of winning the lottery. That's just the truth. And I'm talking about Powerball. I'm not talking about the $500 or the $50 or the little ones. Yeah, people do occasionally win those. But if you look at how much you paid to finally win that $50, you probably bought more than $50 worth of lottery tickets.
I
Okay?
have a friend of mine, this boy I work with,
Mm-hmm.
when he turned 18, he went to the store and bought his first lottery ticket and won $50,000.
Oh my gosh.
You should never play again.
He should never play again.
That's
'Cause-
what I told him.
Yeah, take your money and run, son. But talking about an endowment here, this would have been a smart thing for him to do. Okay, this would have been a smart thing for him to do. He wants to retire 50 years from being 18 years old. Take that money, that $50,000, and turn it into an endowment, and don't touch it until you retire. You can live off the interest on that money probably pretty close to forever. Okay? Now our example says, suppose you'd like to retire in 25 years. So, this is where people have actually got a little older and they learn that you don't spend all your money up front. And you want to have a retirement fund from which you can draw an income of $50,000 a year. His $50,000 is probably not going to pay him $50,000 a year. But you would like to be able to draw that $50,000 when you retire forever, which means you can't touch your initial investment. Okay? You have to live off the interest of $50,000 a year. How could you do it with monthly payments? And it says, assume that you can acquire a constant APR, or annual percentage rate, of 9%. Okay? The question is, how much money do you need to put in right now? Right? How much money do I need to put in right now? Or how much money a month do I need to put in? Okay? This is the way that we're going to set it up. You're going to use only the interest. 25 years from now figures into N. That's 25 years. And let's assume that you could get interest compounded monthly. Which makes sense because we're going to make monthly payments. Okay? And it says your interest rate's going to stay constant at 9%. Now, everybody in here, I passed the Eastman Credit Union this morning on my way in here. Their 5-year certificates of deposit means you put in a lump sum of whatever you got and leave it for 5 years, and the APR, annual percentage rate for that, is 2%. Okay? So this is not likely. I don't want to get everybody's hopes up. This is not likely.
Yeah, most of those bonds never have realistic interest rates.
Yeah, I've wondered because I teach finite mathematics, which is a lot of this stuff, and they put in these outrageous interest rates. And I'm thinking, what planet do you people live on? I mean, it's all right. 18% for a car loan. Well, yeah, if you have to go to Loan Shark, but most car loans now are like 2, maybe 3%. And they talk about mortgage rates of 12%. Nobody would buy a house if we had to pay 12% right now. My mortgage rate's like 3.2% or something like that. The highest one I know was around 6 or 7, so. But anyway, yeah, that's not a likely interest rate for an investment. Okay, now, are we gonna put in a lump sum? No. Because being the people we are, we don't have $200,000 or $2 million to put into this, okay? That's why we're trying to invest so we'll be able to retire someday. So the payments actually are going to be what we're going to solve for. So then the only thing we have left is what the heck is the future value going to be? Well, the future value is going to be the amount that we can draw the income of divided by the interest rate. And the reason for that is because the way that we're going to have that amount is our future value times 0.09 would give us the amount of interest that we're going to get off of that. So the part you need to remember is that this is the principal you want in the future.
So we can multiply or divide?
You divide. Okay? So you're wanting to accumulate $50,000 by the time you retire by making these payments. And then you want to be able to live off the interest from that future value. Okay? So it turns out to be the future value divided by the interest rate. And it has to be the interest rate as a decimal. And the fact that it's an endowment comes from this word here, forever. Which is why you can't touch the principal. So, we will go to our finance formulas, choose the TVM solver. 25 years times monthly payments 12 times a year at 9% interest with no lump sum. We're going to want to solve for those payments. And then the future value is going to be our $50,000 divided by the interest rate as a decimal. Okay? And if you look at this amount here, it kind of, once you've done the multiplication, look at it, you kind of understand why it has to be $50,000 divided by the interest rate. Because you're going to need way more than $50,000 to be able to live off those interest payments. Okay? You'll have to have actually more than $50,000 in the bank, or else the first time you get $50,000 that first year, you're done. Okay? So we're gonna go back up here to where it says payments. How much am I gonna have to put in the bank every month to have that much money when I'm ready to retire? And that much money, by the way, is $555,555.56. So it's over $500,000 that I'm gonna have to accumulate for this to happen. But when we get the payments might surprise you. Because the payments are actually going to be $495.54. Okay? So if you had $495, $496, you know, round it up. If you had $496 a month and put it in every month for 25 years, then you could retire and have a $50,000 a year income with no problem. Now the question is, what kind of income would you have to be able to put that kind of money in the bank? You'd have to have pretty good income to be able to do that. But it's not the amount of money you might have thought, because if, you know, when I looked at that problem without thinking it through, I thought, well, you probably have to have payments of a couple $1,000s a month for that to happen. But with that interest rate, you really wouldn't have. Of course, now realistically, we might not have that interest rate. It has been that high though, at times. So your monthly payments would be $495.54. So you could accomplish your goal with payments that are less than $500 a month. Okay? So that's the idea of an endowment. I think this is, we're about to the end of this. Yeah, we've got total annual return is the last example we're going to talk about. Consider an investment that grows from an original principal P, and you know, an amount you put in the bank, to a later accumulated balance A over a period of time, but not necessarily at a constant rate. The endowment we looked at was at a constant rate. What if it wasn't constant? The total change, the total return, is the relative change in the investment. So your total change is going to be the amount that you have at the end minus what you put in at the beginning divided by what you put in at the beginning. It's kind of like the absolute difference. How much do you have at the end, interest plus what you put in, minus the principal. So it's kind of like the problem we've been doing this whole time, divided by the principal. That's your reference value. The difference in the total return and the annual return is the average annual percentage yield, the APY, that would give you the same growth. Okay? So that's the difference in total and annual. They must be playing with the alarms. So the annual return is the average annual percentage yield, kind of like the APY, that's going to give you the same total return. So let's look at an example of that. you're gonna invest $3,000. You know, maybe you got a settlement, maybe you got an income tax return, but somehow you managed to have $3,000 to put into an account. Over 4 years, so there's going to be a factor of 4 in the end, over 4 years, your investment grows to a final value of $8,400. That $8,400 is a future value. What are your total and annual returns for the 4-year period? Okay, your initial value is your initial deposit, which is going to be negative because you're putting it in, you're spending the money, $3,000. What you invest is your present value. We're going to assume that the payments per year and the compoundings per year is going to be 1. We don't know the interest rate, so that's going to be what we solve for. And we're not going to make any payments. So the N equals 4 is going to be the 4 years times once a year, so it's just going to actually be 4. So let's put that in the solver. Four years, don't know the interest rate. Present value is $3,000. No payments. Future value is going to be, it's going to grow to $8,400. Compounding once a year. Interest paid once a year. Let's go back up and solve for the interest rate. Alpha, enter to solve. All right, what did I, oh, wait, never mind. Sorry, this makes a big difference if you leave out negative signs. I left out my negative in front of my 3,000. It told me no sign change because it knows that PV and FV are supposed to have opposite signs. So let's try that again. And it says the interest rate's 29.356. So 29.4%. Well, no, somebody made a really good investment, although if that was a loan, yeah, somebody had really bad credit. Kind of depends on, you know, if you're on the receiving end or the giving end. Okay, that's the annual return. We want the total return. The total return is going to be a negative change. I'm sorry, not a negative. relative change. Can't read my own handwriting because I made notes to make sure that I did all the numbers right. It's going to be the relative change. The relative change. And you know how to do a relative change. That's absolute change. And the absolute change from 3,000 to 8,400 is going to be, it's going to be positive. So it's going to have to be the 8,400 minus the 3,000. And that's going to be 5,400. And then to do relative, you do 5,400 divided by the reference value, 3,000. And that turns out to be 1.8. And I think that actually comes out even. Yeah. Now remember, 1.8 still has to be changed into a percent. Okay, that is a decimal. So you still have to change it to a percent by moving the decimal 2 places to the right. So that's 180%. So your relative change is 180%, which makes sense because that's a lot of gain. You gain more than you actually started with. Okay? But your interest rate is 29.4%. Any questions before we do another one?
Okay, it says total return and annual return. So are you wanting a dollar amount here?
Your total return,
Is the relative change, so that's the $5,400.
right,
So the annual return,
your annual return is 29.4% per year.
okay, so that's a percent,
Yes.
okay.
Your total return is $5,400, which is a relative change of 180%. But your annual return is 29.4%. And what's happened here, it says you invest. That didn't mean you put it in a savings account necessarily. For example, my retirement goes, I have an amount of money that goes into, some of it goes into stocks, some into bonds, some into certificates of deposit, some into market yield bonds. Because we have to have, if you work for the state, they make sure you save for your retirement. They make you put money in your retirement. But you get to choose how it's done. So sometimes, over the past 25 years, there have been times that I did not want to open my earnings statement because they were negative. And then there's been times I was happy to open them because I would see that I made a little bit more money than I expected to. But my returns actually change. They fluctuate over the years. So what this is actually talking about doing is, this is how much you start with, this is what you ended up with, and it doesn't matter what kind of interest rate changes happened over the period of time. If you know what you need to end up with or what you're going to end up with, then this is the important number to you. That the annual yield is going to be the annual percentage rate is going to be around 29.4%. Some years it had to have been more, some years it must have been less. Because mine is 25 years, where this is only 4. Okay, let's turn that around a little bit. Because this is also a realistic situation. You invest $8,400. Remember, that's your present value. over 4 years, and again, this is going to be once a year, assume, over 4 years, your investment loses in value to $3,000. You're making no payments. What are your total and annual returns for the 4-year period, and what's your interest rate? Well, this time, keep in mind, you're still doing your absolute return. Your absolute difference is going to be negative this time because you lost money. So it's negative 8,400 still, because that's what you paid out. But if this needs to be negative, that's going to need to be 3,000, right? So your loss is actually negative 5,400. And that means that your relative change is going to be that negative 5,400, not divided by 3,000, but by the 8,400. And that turns out to be negative 64.3%. You lost over half of your initial investment. You didn't gain anything. You lost over half of what you put in to start with. Now, as far as your interest rate on that one, it's negative 22.69%. Because remember, it's negative because you lost money.
You want us to round up to 2270?
Yeah, you can round it to 22.7%. Okay? Now, you've got some practice problems to do with this. Plus, you've got practice problems 1 through 4. We've got about 25 minutes left. If you want to take a short break while I gather up the stuff to start section 5, take about 5 minutes.
Where are those practice problems? So where are those practice problems?
The practice problems are in a separate folder in Shobi. Let's see. You've got 2.3 lessons and notes, 2.4 lessons and notes, and then down below 2.5 it says Unit 2 practice sections 1 through 4.
Those are our practice problems?
Yes. And I'm looking at the calendar. Our test over this chapter is next Wednesday. Even though I put it on the calendar that way, I'm actually not real keen on giving exams on Wednesdays. I like you to have the weekend to study.
kinda nice to come in on Monday though.
Yeah.
If you have questions.
Yeah, that's what I was thinking. So what we may do is we may move that test to, Monday the 17th. And then I'll see if I can go ahead and move 3.1 vocabulary up. Chapter 3 is not a hard chapter. Especially not compared to the first chapter. Chapter 3 is not hard. And I'm gonna treat the practice problems 1 through 4 kind of like a quiz. So if you go ahead and do those problems, then they'll count a higher point value on your daily grade. And I will post the answers to those on Sunday night, so you need to get those done by Sunday night.
So the whole unit 2, sections 1 through 4.
Yes, yes, do that kind of like a quiz over the weekend. And
It's also part of our practice questions.
yeah, practice questions on this, let's see, and there's 1, 2, 3.
It's gonna be like 23 through, well, 24, I guess, or 25.
Yeah. So I'll make that change on the calendar, and then I'll send out everybody a message in their mind so that you can remember to adjust your calendar.
What about, are you gonna go over the,
Yeah, go ahead and take a break real quick, and I'm gonna get the portfolios up here so we can look at them. Okay, let's talk about the portfolios for a minute. Portfolio assignment 4 comes from Unit 2, Section 1. You're gonna repeat what you did in the first example, but you're gonna provide the information. And to refresh your memory a little bit, that was when I talked about, I go by Starbucks every morning and I have my little treat to myself for waking up and actually getting motivated and coming to work. I get my cup of coffee. That's the kind of thing that I'm talking about for you. What is your special vice or special treat that you do for yourself? Well, I'm doing this for me, okay? And it needs to be something you don't mind telling me about. I want you to calculate about how much you spend on that little treat for yourself every year. Doesn't sound like much on a daily basis, but calculate it for a year. And show all your computations. Show me everything that you put down. Then what is a necessary expense that you have? That you'd rather not have to pay, but you're kind of stuck, you do have to pay it. For me, that would be like car insurance. I really hate paying car insurance. Or your electric bill, or gas. I mean, most of us don't mind paying for food. We all kind of like to eat, but, there are things we have to pay that we don't like to have to pay. So pick one of those and calculate how much you spend on that expense per year. And again, show all your calculations. And then your last question says, divide the first expense by the second one, your treat divided by your necessary evil, to find what percentage of the necessary bill you spend on your treat. You might be surprised. Portfolio 5, I'm going to let Miss Dabney tell you about.
Here's our instructions for the report. I'd like you to work this along with me, so you understand, because part 3 is gonna be for you to do on your own.
You're not gonna do it on discussion,
So,
board, you're gonna answer it.
yes, imagine
in
you
the
recently got
portfolio.
a new credit card, and you didn't pay much attention to what the terms of use are, the APR is,
Can you turn up a little?
and with this card, it's 24% interest. To make matters worse, you go out and spend a little more than you meant to, and the first day
Well.
that comes, you're surprised to find out that your new balance is $876.
Let me pause it a second.
Well, you have a little time to
I don't know what happened to the volume control on the taskbar here.
answer on the discussion board. So the setup is, imagine you recently got a new credit card and you didn't pay much attention to what the terms of use are, the APR is, and with this card it's 24% interest. To make matters worse, you go out and spend a little more than you meant to, and when your first statement comes, you're surprised to find out that your new balance is $876. Well, you have a little time to decide what to do. Usually you have a grace period of about 20 days. So on the statement it says you can pay a minimum payment of $20. Of course, you can always pay the full balance, or you can pay any other amount in between. So we're going to do each of these things. Option one is we're going to pay for the whole balance in full. Now, most of the time you can't do that, but this is just to sort of give us a place to start from. So if the balance is $876 and we pay the entire $876, then our remaining balance is zero. You're only charged interest on your remaining balance. So since there is no remaining balance, there is no interest. So we paid the credit card company $876. All of that went to principal. So all 100% of our payment went to paying off the principal. 0% went toward interest. Now that seems a no-brainer, but let's look at option two. Option two, we're going to pay the minimum payment. The minimum payment's $20. Now, if you have a credit card, you realize that every time you make a payment, your minimum payment will change. Usually it goes down. So if you, as long as you paid on time, it'll go down. So while it says the minimum payment is $20 this month, next month it might be like $19.86 or whatever. But we vowed to ourselves that we're going to at least pay this $20 every month, and we will charge no more because we've learned our lesson. So if we start with a beginning balance of $876, this time the payment amount we're going to make is $20. So if we take $20 off of our balance, we end up with $856. Now, since that's the balance that's left over, that's the amount that gets charged interest. So let's stop and talk a minute. You can look at your sheet up at the top, or you can recall our interest for this credit card was 24%. That's APR. So we make monthly payments. We don't get charged 24% every month. It's 24 divided by 12. 24 divided by 12 means the interest we pay is 2% each month. Now, I could take 2% of the 856 and then take another step to add it back. But really what I want to know is how much am I going to have as a balance next month if I add 2% to what I have. That was our two-step problems, our shortcut. If we're going to add 2%, we add it to 100%. That's 102% is what we multiply. 102% as a decimal is 1.02. And that'll tell us how much our next bill is without me taking two more steps. It's just in one. So 856 times 1.02 means my new balance is going to be $873.12. So in the second month, that's what my bill is. Now, I'm going to do the same thing I just did. I'm going to pay $20 and see how much I have left. Then I'm going to add interest to that amount. So again, it's 2% interest every month. So if I add 2% to what I already have, and I do it in one step, I'll multiply by 1.02. And now my new balance is $870.18. Now, if you're feeling frisky, you would pause me right now and see if you could do the next one on your own. Now, you're probably not going to keep up with me. I'm trying to talk slow, but if you're trying to write and use your calculator, it's hard to
There's
talk
a
slow
link to the
without doing
video
it
at the end of the portfolio, so you don't have to take the notes.
the next month, you start with the $870.18. That was our new balance. Pay your 20, see what you have left, add 2% interest, and there's our new balance. So that's 3 months in. We want to do this 2 more times. Here's my new balance. I'm going to pay $20, see what I have left, add interest. There's my next month's balance. So one more time, I'm going to start with $864.12, pay $20, see what I have left, add 2% interest, and on month number 6, I would get a bill for $861. So here's the questions we want to consider. How much did I pay the credit card company this time? Well, if you look back at our columns, we paid $20 every month for 5 months. 5 times 20, we paid the credit card company $100. How much did the balance change? Well, it started out at $876. 876 is down to 861. Do that subtraction and weep, because your balance only decreased by $15. I paid the credit card company $100, and my balance only decreased by $15. So what percentage of my payment went toward the balance? Well, 15 out of 100, I don't need a calculator for that. 15 out of 100 is 15% of the money that I spent to the credit card company went toward my bill. 85% of the money that I sent to the credit card company, $85 out of every 100, went toward interest. That's just free money for the credit card company. So even if you don't have $876 to mail in a check right now, I think we could do better than that. So here's your part of the activity. You're going to choose an amount to pay. And you're going to pay it for 5 months. You're going to repeat the steps that I just did. Only you're not going to use $20. You're going to use something more than $20. Now, I don't want this to be, I don't want you to be able to pay it off, so I want you to use less than $100, but more than $20. Well, you could use $100.
I think yours limits it to 50.
No two of you can use the same amount, so when you list your discussion title, put the amount of money that you paid in the title. So you're going to pay that amount for 5 months, and then answer the 4 questions that I asked at the end of option 2. How much did you pay the credit card company over the 5 months? How much has the balance changed? What percentage of your payment went toward the balance? What percentage of your payment went toward interest? And at the end, discuss whether or not you find that reasonable. Now, there's not going to be free money, so you're going to have to pay a certain amount of interest. But at least discuss whether you found the percentage is more reasonable than what we have with the minimum payment. If you have any questions, give me a holler. I'll see if I can answer them. But really, I think the best way to answer your question is to follow along step by step with what I did in option 2. Thank you.
Okay, so that gets you through most of the project. Actually, you only have to do the very last part. Last for this section. And the choice you have for option 3 says choose a number between $20 and $50.
So do we still have to have this income tax thing done on Saturday?
No, I'm gonna move the due date on that. That's why I put them all up here.
Okay.
So she said nobody could use the same amount. How do we know what everybody's gonna use?
Okay, what I'm gonna do, in order to make sure nobody uses the same amount, is I'm going to send you an amount in your folder. Okay, I will tell you what you're gonna pay.
Okay.
Some people will get 25, some will get 30, some will get 35, some will get 40, some will get 45, and some will get 50. Okay? And I'll just randomly choose from those. There will be probably more than one person that will have the same amount, but you don't get to pick what that is. I'll just tell you what to use. And this is the link to the video if you need to go back and watch those steps again. Portfolio 6 is house or home. Find some basic information on the house that you have, or find a house that you reasonably like to own. You can use your local newspaper listing to do that, or you can go online. In either case, I would like for you to, show me what you found. What's the selling price of the house? Find the monthly payments on that house without taxes and insurance for 30 years. And that's assuming you're not going to make a down payment. You're going to be able to get 100% financing. Use the lending rate that you have, or 5.016%, if you don't really have a loan. That's, at the time that she wrote the activity, that was the current average fixed APR for 30 years. I think it's probably a little bit lower than that right now. And the reason we're not doing the down payment is because it would be tricky for everybody to figure out what their down payment would have to be, because that varies by lending institution. And it varies by your credit score. So it'd be a little tough for you to have to deal with figuring out what the down payment would have to be. So we're just going to assume you can get it. We're just going to assume off the top you can get 100% financing. And then how much would you pay total for the house? If you're going to have a 30-year mortgage, you're going to make 360 payments of whatever the payment amount you come up with is. Okay? And then find the monthly payments if you had a 4.312% interest rate, or if you have another one, you can use that for a 15-year mortgage. Not 30, but 15. And then how much total would you pay for that house? And then which option would be more reasonable for you? Which do you find to be the better option? Now, those 3 portfolios need to be done. I'll keep 4 and 5 due before next class, but I'll probably move 6 and 7 to the weekend before the test. And the last one is about taxes, and you realistically can't work on that one yet, so I will be changing those due dates. Okay? So you all are free to go, and I will see you on Monday. Sure.
I'm not, this last 3 portfolios,
I kind of forgot.
I misunderstood. And I did them.
Oh, but you didn't turn them in?
Yeah. And I didn't, Kristen asked me, she messaged me, asked me about the 3rd one. And I was like, I really got lost on it, so I did 3 quarters of it. I was like, yeah, I just sort of gave up on the last one. She was like, oh, I don't give up on one. Like, I just, and for some reason in my head, like, just didn't, I don't know, like I just misunderstood how difficult. But I want to make sure I stick to it. I nailed it the next 3.
Okay, send me a text and remind me that you forgot to turn them in. You did do them, but you forgot to turn them in.
I got them back.
Okay, and I will open the Dropbox back up for you, let you turn them in.
Thank you so much, because
I wondered because, you know, you have such good grades, and then I saw that you didn't turn them in. I thought, did he forget or not realize they were due?
no, I don't know what I thought. Like, I misunderstood, like, not that they were optional, but I didn't also get used to this due date thing. I've been
Yeah.
in school for a long time, so
Oh, I know.
But like, sometimes I'll just do the thing and then take a picture, and I should have taken a picture of those as I did them and turned them in.
Yeah.
But I thought like they all had to go in at one time, and then I missed the due date on the 3rd one, so I was like, well, I can't turn them in now because I didn't do it. Like, I didn't finish it all the way, and so I was like, well, I guess I just can't turn any of them in. So I kept
Always talk to me if you have a question. Yeah, I mean, the worst I can say is no.
and I didn't dawn on me that what I didn't do until like I got saw my grade. I'm like, oh my god, I failed all 3 of those, but I did them. I was like, I don't know.
Yeah, because that really dinged your grade.
Yeah, and I started to panic. I was like,
Nah, you'll be okay.
okay, cool. Thank you so much.
You're welcome.
I'll take a picture on my break right now.
Okay.
And submit.
Just, you know, like I said, you need to remind me that I'll need to fix it for you.
Thank you so much.
Okay?